But if I wanted to prevent brain metastasis for myself, like for my own cancer, wouldn't it, should I be looking for drugs that target this? Even if it is targeting all the other cells, I don't want to have brain metastasis. So shouldn't I be looking for, or like, shouldn't we be funding research that supports drugs that will target this?
Um, So I obviously can't speak to clinical context as a basic
Oh, I
scientist,
forgot. That's right. I'm
but
sorry.
yeah, but also, yeah, it's one of the things that we wouldn't want to look at direct impact on Rab11B. So I'll actually get to the family interacting proteins and what we've seen with that in a moment.
But
Good
I would
question,
just add to
Christine.
that we should definitely be funding research into metastatic cancer and metastatic breast cancer. And that is a big part of the reason why the work that all of you do is so important with GRASP. And I know several of you at least are involved with MetaViver, and that's a big part of how you're able to help work together with us to move all of this forward.
Thank you. Oli, I did have a quick question. When
Yes.
you mentioned you were answering Bob's question about how we wouldn't want to get rid of RAB11B because it's needed for normal cell functioning as well as for the cancer cells. How do you differentiate between RAB11B on a normal cell versus a cancer cell? And how does that affect your research, the research that you're showing us today? What is the value of looking at RAB11B's role in cancer metastasis into the brain if we don't want to, as you said earlier, knock it down or decrease it because our normal cells need that? Can you explain that a little further? And maybe Erin, you could weigh in on that too.
Yeah. So if you don't mind, Oli, I can sort of big picture conceptualize that.
Sure.
So basically, a lot of normal cellular processes, normal things that happen in all kinds of cells, become messed up in cancer cells. And most of our clinical therapies actually target those normal processes. Um, I know Janice has triple negative breast cancer and has taken doxycycline or anthracycline. And that targets cell division. Your normal cells have to divide. And even a lot of our targeted therapies, our immunotherapies, which have really limited toxicity, I know there's still some, but compared to chemotherapies, it's really decreased, right? Those are also normal cellular processes. And so it's not necessarily finding things that are unique or completely new in cancer cells in order to be able to come up with therapies. It's finding things that are a little bit more specific that the cancer cell really relies on, and that normal cells, you're sort of able to tamp it down a little bit, but losing that is really detrimental to the cancer cell because it really relies on it. Did that answer
Thank
sort
you.
of
That
conceptually?
yes, actually it did. So basically what you're targeting is the proteins that are broken in the cancer cells. They work in normal cells, but they become broken in cancer cells. So that's what we're targeting?
Yeah, a lot of times there'll be more of something, which as breast cancer patients, HER2 is a great example. There's a lot more HER2. Your normal cells have HER2, your heart, your cardiac muscle cells also have HER2. But because those cancer cells are so dependent on it, that's why targeting it is clinically effective.
Great. No, that was very helpful. How about the rest of the advocates, Christine, Michelle, Bob, and Maggie? I just want to make sure that you're still with us. If you have any questions, please feel free to ask. Did anybody else have any other questions before we move on?
I just wanted to say thank you for asking those questions, Janice. I was a little afraid to ask them, but I appreciate that you did.